a short discussion on vacuum chucking. So first of all, why do we want to have one, and what's the value of this thing? I think completing the bottom of a vessel, completing the foot, getting rid of the tenon is one of the things that it first comes into use for. That ability to turn something around without jam chucking. The second thing is the possibility of rechucking again. There's some projects I've done and I thought I had it all completed and everything looked really good on the bottom, and I wanted to put it back on the lathe for some reason. So it gives me a way of putting things back on without marring up the surface or doing anything else. I do sand with my vacuum chuck. Slap a bowl on, sand the outside, flip it around, slap it on the vacuum chuck again, and sand the inside. So it is a sanding fixture, as long as you protected your components, which I'll talk about. There's several components, and basically the way I see it is you just have to have some way to lower the atmospheric pressure inside the vessel. In other words, so the outside atmosphere pushes on it like we want it to. I've got to find some way to connect the system through the headstock, so as the lathe rotates, I can continue to suck and have no loss through the connection and continue to suck. I need to find some way to vary. I could crack it. In fact, one of the things that happens when you're first beginning to work with vacuum chucking and cranking it up too much, you begin to hear things move that you don't want to have move. And then, of course, you have to have a chuck. And there are commercial ones, and then there's handmade ones, and I'll show you how I make them. And because I choose to filter sand, and sometimes just because there's debris accumulated in the pores of the wood itself, you have to have filters, inline filters, to keep your pump, your gauges, and all the different components protected from wood debris. They're inexpensive, easy to put in and change. One way to generate vacuum, and this is one of the early ones that came out, it's still in the market. This is from a company called Holdfast, and it's still in the market, but it's not inexpensive, and it requires you to use your compressor. You use the compressor to blow air through a venturi orifice, and that creates a vacuum. This pulls a pretty good vacuum, but it does require the use of a compressor. And of course, the compressor is running constantly, and most of ours are not that quiet on top of that, but it's one of the options. Most commonly used are this kind. This is what we have on the one on the robust lathe. This is the same pump that we used on the one-way lathe when we still had it at the club. And these are called rotary vane pumps. They're not necessarily very quiet, but they provide high CFM, high cubic feet per minute. In other words, a lot of volume. They also pull a pretty decent amount of vacuum. You turn it off, the vacuum's gone instantly. These are pretty expensive, but there are places that you could buy rebuilt ones. There used to be a electronics surplus store down in South San Jose, and I could always find vacuum pumps down there. These were used in the semiconductor industry, either for test installations or projects. For the bigger depositions in the semiconductor industry, they would not use something like this, but everybody had them for the small test sites, so there's always pumps available. Sorry to say the source is not there anymore. We're using one of these at school. This is a diaphragm pump. It's inexpensive. It lasts for almost forever. It's totally non-destructible, it seems. You fill it with oil, and it uses regular compressor oil. There's a little gauge on the end of it so you can see if it's got oil in it. They're very quiet, and they're inexpensive, and they're available to Harbor Freight. This is the one I have at school. It's a 2.5 cubic feet per minute pump. They have a larger one, a 3, and I think it's only like $50 more. Works fine. Works fine. It doesn't have quite the volume of vacuum that the other ones do, but it works really fine, and it's super quiet and obviously inexpensive. There's other ways. Rick Nelson did a Sawdust session for us a few months ago, in which case he talked about vacuum chucking, and he was using his shop vac. And he hooked it up, instead of sucking dust up and into the vac, he hooked that suction up to the headstock of his lathe. And for fairly large projects, it provided enough suction to be able to allow him to finish his bowls. So it worked out really, really well. Of course, they are fairly noisy. You could take that compressor we talked about earlier, and instead of having it blowing into a tank, building a pressure, it could be used backwards to literally suck the air out of your vacuum chuck system. And we talked about refrigeration compressors. They work really, really well. They're super quiet, provide excellent vacuum, but the flow rate, the CFM, is not really very high. So if I put a big bowl in there, it may take a few seconds for it to build up sufficient negative pressure to hold that piece in place. We used them for a long time. Hal Bain, I mentioned his name earlier, was a club member at one time, and his professional business was refrigeration, specifically ice machines, repair service. He ran a company that repaired commercial ice machines. Ice machines are a refrigerator, all had pumps. Some of them were pretty big pumps, and that was pretty nice. We just simply pulled I'm going to call it Freon. It's not Freon anymore, but it pulled the Freon out of the system and just hooked it up, and it worked fine. The problem is that Freon-like material, as it circulates through the pump, is a lubricant. And without it there, you're destined to eventual failure. I had one, and I must have run mine for 2 or 3 years, and one day it just froze up and it was gone. But it is an option. It is an option. By the way, you have comments or questions, please just feel free to speak up and insert that as we go. Various kinds of adapters. Here's the 3 classes. There's the kind that fits over the hand wheel, like the one in the center, the one-way adapter, which I'll show you in a minute. There's ones that fits inside the bore of the headstock. The one pictured at the top can be taken out and replaced in a second, so you don't have to leave it in place. The second one over the hand wheel generally stays in place until you unscrew it, and then if you need to use a knockout bar, you've got to take these things off. The third one is the cheapest one, and it's a cheap way of doing things. It actually goes through the bore of the headstock, and the little button in the upper left corner seals at the threads of the headstock at the taper. The rod passes through, and the rotary adapter is on the outside of the hand wheel, so it can be put through the headstock, the little knob screwed on the end, and it's done. It's in place. The advantage of each of these, each have their own individual advantages. The bottom one, if your system has any leaks at all, it seals tightly in spite of the fact there may be leaks in the bore of the headstock. So,
question, Jim, on that.
Yeah, go.
How do you release the spur drives when you have these in permanently?
How do I release?
How do you get your spur drives out, or if you're using it, using it between centers?
Thus is the problem. What I use is for a spur drive fits in the 4-jaw chuck. And so I screw my one-way chuck on, and it has an adapter that sets at the base of the jaws. That is a spur drive. That's the way I do it, simply because otherwise I would have to take it off or remove it to get my knockout bar in. And that is the weakness of that one-way one that's pictured in the center. Yeah, you have to take that thing off, create the bore open so you can get your knockout bar in there. So I just don't use a device that requires a knockout bar. Now, every now and then I want to put the drill chuck in the headstock, and now I'm stuck with having to take that off. And to remove it, I loosen one set screw, which locks in place, and it just unscrews. So it takes 10 seconds to take it off, but it is pain in the rear. I'd rather not do it, Jim. Good question. So the through headstock, there's 2 different ones on the market, one from Holdfast and one from a company called Stickfast. Believe it or not, similar names, similar items. it consists of a piece that fits into the threaded end of the headstock tightly, and a rod that passes through the whole headstock bore. Generally, they're lap rods. They're really cheap lap rods, and they come very long, and you put it into your lathe and you cut it off to length. So one adapter will fit anybody's lathe. And then the rotary part is on the outboard of the hand wheel, so you still have your standard hand wheel to work with. They're not too expensive. The right-hand side of this picture here, you can see the part that seals at the headstock, and the rotary adapters on the left-hand side. They're inexpensive. They work fine. I don't have one. I did have one. This is the one that we got with our robust lathe. And the top left-hand side of that, you can see two O-rings that fits snugly into the bore of the hand wheel. And on the lower right-hand side, there is a 1/4/8. I think it's 1/4/8. I'll have to measure that in a second. Thread that you screw your fittings onto. And the one we have at school is all fitted up that way. We just simply jam it into the headstock when we need it and then remove it when we don't. I'll take that apart, show you what it looks like in a second here. The third one is something that replaces the hand wheel. This is the one-way adapter. It's the most massive and biggest. When it's replaced, it becomes almost like the hand wheel. We have those Jet 16 EBS lathes in the classroom, and their hand wheels are about the size and shape of that adapter itself. So I leave mine in place, and that is my hand wheel. We have one for the Powermatic, and the Powermatic has no threads onto the hand wheel. And as a result, you've got to have an adapter that fits for the Powermatic, and they have one. They have one for every lathe. So you use an adapter like you would put inside a chuck and fasten it in there, and then it screws onto your hand wheel. Those are the three different kinds. Yeah, you can build your own. We have in a couple places built our own. The Jet 16 EVS, for instance, has a very long cylindrical aluminum hand wheel, which is easy to machine. And you can machine that out, fit a double sealed bearing in the end of it, and then simply plug your pump into it with an O-ring, which is exactly what we do on one of our lathes at school. It works fine. You gotta have chucks, and there's a lot of commercial ones. I have 2 of the 3 one-way chucks at home, the smaller and the middle-sized one. They're really massive. They're solid aluminum. The edge is radiused, and that looks to be almost 3/8 of an inch thick, and it is. You put an adapter on it so it'll fit anybody's threads. That's just fine. The phenolic ones, the holdfast ones, are phenolic, much lighter, and they're also managed with threads. What I like about the phenolic ones is, first of all, they're light. They have 2 O-rings on them, one sealing the inside edge and one on the outside edge, which allows you to put something over the chuck and seal it that way. Or given the shape of the piece you're working with, you can actually put it inside the chuck and seal to that O-ring also. So they're pretty nice, and their threads, you can buy them with 1x8, 1¼ x 8, 33 millimeter, and so on. So you get options, and the stick fast is very similar. I don't know anybody who uses the stick fast chuck, but it is available. And as I said before, I build my own, and I kind of enjoy doing it. It's kind of a fun thing to do, but I can adapt it to the specific projects. And if I have something very small, I'll make a small chuck. If I have something very long, I'll make a longer one, and so on. And I'll show you all the various steps to it, but there are a few caveats. When I first got into this years ago, I was at the one-way manufacturing booth at one of the AEW symposia, and I was thinking about building chucks and so on. And the lady in the booth says, whatever you do, don't use MDF. And I said, why? She says, eventually it'll just totally disintegrate. The vacuum will just suck the particles right out of the fiberboard, and it will just basically blow up. And it's for the same reason you don't want to use plywood. There's too many leaks. Yeah. The surfaces of the plywood are porous. And so if you made it out of plywood, then you'd have to go around and seal all the edges And you can do that. I've sealed it with all sorts of different materials, but it's so much easier to work with non-porous materials like acrylic.
You know, Jim,
Yeah,
can you hear me?
yeah, I can.
On CNC machines and stuff, what people do is you'll use MDF like say an 1/8 inch sheet, and they lay that down, and they have their vacuum underneath it, and they can pull a vacuum on sheets right through the MDF.
I have never experienced that because I never made a chuck out of MDF, so I avoided the possible problem.
Yeah, I don't think I would make one out of it. But
Well,
yeah.
I've made it out of solid wood, and then I've had to go around and seal every surface because all woods are porous enough that they have some leakage.
Yeah.
Unless you have a high CFM system, high cubic feet per minute, high volume system, you're going to waste vacuum passing through the porous wood itself. So I avoid that. I have made some that actually I sealed with the whole surface with epoxy. I just painted it all over all the wood surfaces after I got the chuck done, thus making it totally sealed. That works. Looks bad, but it works. Components in the system. Basically, you have your adapter. I'm using a filter, an inline filter. You can pick them up. I used to pick them up at Harbor Freight, 2-bag. They had them at Rockler for a while. And I bought a box of 20 of these things on eBay. And I must have paid a total of $10 or $12 for the dozen. So they're really inexpensive. They screw right in. They're 1/4 inch NPT fittings on both ends. So you screw them in, and at some point in time, you unscrew it, throw it away, and put another one in. They're inexpensive, but it's got to be before your gauge and pump in order to keep the dust out of all the fine workings. Hardware wise, I've chosen to use all brass. Brass is a little softer than the steel. I think they seat better. If you go to your hardware store into your plumbing fittings, you're going to find all the little fittings that you need in all the different shapes and sizes everywhere. They're just all there. I'm using 1/4 inch NPT fittings. So by that, I mean, it's a 1/4 inch diameter. NPT refers to National Pipe Thread. It's a standard. And the reason we're using those is they are slightly tapered. So as you screw the components together, what ends up happening is that they continue to seat more and more snugly, and they're designed for lossless connections. So you can go to the hardware store and say, okay, I need an elbow, I need a Y, I need a this, I need a hose barb on one end. You can pick them all up, and I've priced it all out here in a couple of minutes, and I'll show that to you. All those components, I don't mean for you to write this down, but I went to Harbor Freight and picked up all those brass pieces that I needed. The Teflon tape. I went to the hardware store and got 3 feet of the nylon impregnated tubing that I like to use. And I went online to Amazon and ordered that big vacuum gauge. I like that big one. Total cost was approximately, for all that stuff, was just right about $50. So it wasn't expensive. You are stuck with one other thing. You still have to buy some sort or build some sort of an adapter, and you need that pump. And then of course you have to have a chuck. So, but from the hardware point of view, not very expensive at all.
Jim,
So yeah, go for it.
say instead of using Teflon tape, Loctite makes a special like a liquid that you can put on the threads that's far superior than Teflon tape for vacuum. It's designed for vacuum and stuff like that, high pressure, and it seals. Just, you don't even have to really tighten it that good and stuff, and it bonds. And the tighter you get it, the more it sets it.
What Michael's talking about is this Teflon tape, which is really inexpensive, and it's just super thin. And you wrap it around the threads and then screw your components together, and it provides an additional seal. This roll of Teflon tape feels like it's no weight at all because it's so thin. But that's what we're talking about. And we're talking about the units. This is the adapter from our Robust. This part goes into the spindle, and this part fastens to our hardware. And here are two rotary bearings. These are what are called double seal bearings. You can pick them up at all the bearing dealer of different sizes. You can get different bores, different diameters if you want to build your own. This is intended to fit snugly into here. And if I don't put it back very carefully, I can wedge this thing pretty badly. But it comes apart, and it shouldn't do that. So what I'm going to do is I'm going to seal these two bearings in here so that when you pull this out of the lathe, you don't end up disassembling it accidentally. I'm surprised it's not completely done. Let's put it that way. And these two O-rings seal the bore of the robust. So it just slides into the hand wheel like that. And when you're done, just make it go away.
Jim, this is Dave.
Yeah, Dave.
I just checked at Amazon and they carry that little air filter for $3.66 that fits in line for the vacuum pump.
Oh, nice. $3.66. That's a good price. That's a good price. So what I wanted to show you next, if we're ready to go on, I've set up my system, which has a rotary vane pump and a gauge. I've set it up on the Powermatic that we have at school. And the reason is that I can plug it all together, and I want to show you the pieces put together. And then what I'm going to do is I'm going to test it. And I'm going to test it with a test piece, and I'm going to put a bowl on with two different size chucks, and you can see the amount of difference in the holding pressure that we can actually get. So if you want to go on, now these have been taken out of videos that Dave and I put together earlier. So this is setting up one. Let me show you how that works. I've moved back to the old Powermatic. I set the vacuum pump up on the counter behind. Generally at home it'd be on the floor. This is that power extension I had. Plug the pump into that. Sits on the end of the lathe on a permanent magnet. So now to install the rest of the system, I have to remove the hand wheel. And that means I loosen these two set screws. Pull this off. On this particular lathe, the shaft is straight. And I've installed an adapter in here that slides onto that. There is something to be considered. Now, this is an important thing. This shaft has a slot in it for the set screw to sit in. If I screw this adapter on, that slot is going to proceed all the way through the end, and it's a potential leak. So what I have done is in the base of this, I've dropped an O-ring. So when I slide this on, it's going to seal right to the end of the shaft. So now I'm going to put it in place, slide it on. I know this is a 4mm screw. Tighten it down. And I think there's just the one. Okay. So that's installed. That's done. Now what I'd like to do is to flip this over here so I can see my gauge. I've got my valve open, filters in place. Now for my own personal convenience, I broke this hose into two pieces. It makes it easier for me to transport. So here's that quarter NPT fitting again. This is the gas fitting, so it fits in here nicely. Screw this together. And to make sure it's nice and tight, take a small crescent wrench. Give it just a little bit of a snug. So the system's together, it's done. So on the other end is going to be a vacuum chuck. I'm going to step down to the headstock side, and we're going to begin to operate this a little bit and see what a vacuum chuck actually does. So I thought I'd give you a quick break on that thing. I did cut that hose in half, and I did it intentionally because I rearrange it sometimes, and I've hauled it with me a couple of times, and by being able to disconnect everything like that, it gave me a chance to carry the chuck in one hand and the pump and everything in the other hand. I did want to show you one thing before we go on again. This is the hose, the way I particularly choose to set it up. It's a little bit bigger here. I like this nylon coated hose. It tends to not collapse. My fittings have gone in here. This is a hose barb on this end, goes into the end on both ends. And then I've got clamps, an additional security. I put these clamps around. This is a kind that you just crimp. And the one on this end is a screw, and you can get either kind. They'll have them at the hardware store. But my choice is that kind of arrangement like that. Just to, and there's a little bit of what the Teflon tape looks like when I have it in place. Things backwards here. I've got to be careful where I hold things for you. But that's what it looks like in my system, a short version of that. So I want to show you the test, how we actually make this thing work.
Right now, no vacuum. We close the valve. Seal the spindle. And I'm pulling about 23 inches of mercury. So given the atmospheric pressure and the inefficiency of the system, that is my maximum I can get. And as I open this valve, there's 15, there's 5, and by bleeding this, I can adjust the amount of vacuum. So let's put the large chuck on. Seats snugly against the spindle. Hold the bowl on. Now, given the perfection of the finish on that bowl and the quality of that chuck, I'm pulling approximately 18 inches of mercury. So that's pretty snug. That's not going anywhere. For me to get it off of there, I have to open the valve. Let's take this one off. Put the smaller chuck on. Remember I talked about less square inches, less pressure. Same system. Now, because I'm holding vacuum in a smaller area, less surface for it to leak, believe it or not, I actually have 21 inches of mercury, but I only have it over a small area like this, so the total amount of pressure in that bowl is far less. Can I get this off? With a little bit of force, I could pull it right off because there is less atmospheric pressure pushing it on. How the system works.
So square inches of surface, we're talking about at sea level under standard temperature and pressure conditions, which never happens, 14 pounds of pressure per square inch of surface. So if I had a chuck that had a diameter of 2 inches, that would be about 35 pounds of pressure. If I had one twice as big, 4 inches, it'd be 12 times 14. It's about 150 pounds of total pressure. That's not accurate, but that's close. So the key is it's the area of the surface that's being touched times the pressure per square inch. In other words, how many square inches times 14 gives you the answer to that. So here's some options. These are 3 I've made. These 2 chucks are going to hold the same vessel differently. The smaller one is going to, I'm going to be able to jerk it off easier. The larger it becomes, the more help it has in holding on. This is what I wanted to show you because this is a vacuum chuck. So I took a faceplate. This is wood, piece of wood, sealed it. And then I went to Tap Plastics and I bought some mold release. It's 2-part compound. And what I did is built a dam around this, put a straw in the center, leveled it so that on my workbench, it's sitting dead flat. And I poured the mold release compound in there and went to bed. It took almost 24 hours for it to set, but this is rubbery, but it has a very thin layer. I don't know if you can actually even see the layer thickness on there. It's less than an eighth, maybe 3/16, 3/32, I should say. If I have a project that has a really flat opening, I can put it on there. I have one just like this that is 12 inches in diameter. I did 2 of these when I made them. The larger one I have used from time to time, very seldom, but I have used this one. So, I mean, even things like that are vacuum chuck. So we've got lots of different options. And the ones I've made come in all sorts of different sizes, but they have a lot of common features. Here is the one I told you that I made out of wood. I used what's called a fender nut. This is a 1x8 thread, and this is known to be dead flat. These are used in bridge construction. And so I buried that fender nut in a piece of wood, species unknown. And then I buried my tube, my chuck material into that. And then I epoxied this whole surface everywhere. Be sure there's no place that the air can leak through the fibers of the wood. And then I went ahead and built the chuck up. Most of the times I have used acrylic material. It's been my favorite way of doing things. Several reasons. First of all, this is not going to leak. It's not porous. It's not going to leak at all. Second thing is I can cut threads in here and screw the faceplate on with a threaded screw, and each of these holes are going to seal very well. In this particular case, the chuck is inside of those threads, so there's no possibility of a leakage. But in this one, the threads are inside, the screws are inside, but they've been sealed. So I like working with acrylic. I screw this on, face it flat, screw it in place, dig a groove, bury my chuck body in there, square it off at the top edge on the lathe. Make sure this is running true to the face of the lathe, and then add a seal material on the top of it. Seal material comes sort of like this. It's very thin, closed sale foam. I get this at Michael's. I think Hobby Lobby also carries it. When they sell it, they recommend a particular type of glue. It's a little white glue, a little tiny bottle, about that big. I think it's the same thing as standard Elmer's white glue. But I haven't chosen to use this. I've always stuck with theirs simply because it works. And maybe one of these days I will try an experiment where I'll actually use other white glue, put a bead around here, put this on it, and see how well that seals up. But that's the process.
Question for you, Jim.
Go, please.
Is there a vacuum loss through the threads? And do you do anything to seal that area at all?
In this case, there is no vacuum loss through the threads because this hole is outside of the chuck.
I'm talking about the headstock, that one there, yes.
Oh, yes. That's a great question because it has been a problem on certain lathes. If the bore of the headstock is a solid piece of metal going from the threaded end where we screw our chucks on to where we attach the vacuum attachment on the other end, then we're in good shape. But if the lathe has a speed indicator on it, such as one of these digital readouts, many times they've drilled holes into the body of the headstock bore, put bolts in there, which then a sensor then sees coming around in a circle and then reads RPM. But each of those can be a leak. So specifically, the Jet Model 16 EVS, of which I have 7 now, has that problem. And one day I was setting that up with the Chuck, and Chuck Cottrell came into the classroom. He says, I'm going to fix your 16 EVS so it has good vacuum. I said, oh, I didn't know it was not going to. He said, yeah, it is. He opened up the headstock, pulled the screws out, put Loctite on them, and put the 4 screws back in place again. He says, now it'll be fine. That was the place where it really did leak, Jim. And the problem was around those individual screws. So if the lathe has a hole in the headstock bore of some sort, then that has to be sealed. In the case, that's the only one I know of where that's been a problem. It's the fact they drilled in there and put a screw in it, and the screw was not seated tightly. Drop of Loctite did the job. Good question, though. I would never figure that thing out. I would have figured it's my system was having a leak, and it really was the lathe itself. The test is, like I showed on that machine, you hook up your vacuum chuck and you put a flat piece of rubber over the bore, and you see what your reading is on your gauge. And if it's not reading full vacuum, you know you've got a leak. And then with it running, you can start testing to see if it can find it.
Hey, Jim, this is Dave again.
Yeah, Dave.
That glue that you used on that it was made by a firm called Creatology. It was called foam glue, clear drying. It's for foam, wood, and plastic.
Wood and plastic. So the question is whether it's like Elmer's white glue or not. I don't know. I have just never tinkered with it. The stuff is cheap enough, and the bottles are small enough. They do dry up after a while. After a while, meaning if I have it sitting on my shelf for a couple of years, I probably ought to go buy another bottle. But Dave, did you check to see how much they were?
When I bought this, it was like $1.50 or $2 something.
Throw it away after a couple of years. Don't mess with it. Yeah. The sheets of this closed cell foam were like 12 by 16. They're big, and they were 99 cents a sheet. So, I cut out the hole for this big chuck, and outside of the piece that came out of here was enough to make that one and that one, and it still got stuff left over. So the key is that foam lasts forever, and eventually you'll tear these up. Something will slip, or you'll abrade it in some way or other, and you'll need to take it off. So I go in there and take a skew chisel, and it comes off in about 3 seconds. I put another piece on at practically no cost. And remember, when we use jam chucks, we always left that little indentation from the spur drive in the bottom, so that when we put it on the jam chuck, we'd have a way of getting it perfectly aligned. The effect is exactly the same. You can use that mark. I have a tendency to leave my project in the chuck tenon and screw that chuck onto the tailstock with my one-way live center. And it has a thread adapter, so it's perfectly aligned. I just bring the tailstock up, slam it against the chuck, and it's dead center. But if you don't do that, always remember to leave that little dink in the center, put on initially with the tailstock live center. When you're first forming your tenon, always leave that little dink right in the middle, because that's your alignment at the last step. Whether or not you're using vacuum or just a jam chuck, you need that to get that positioning just exactly right. If you take it off, then you put it on with very, very low vacuum, so things will slip. And then by hand, rotate the spindle and check it against maybe the edge of a tool rest to be sure whether you're centered or not. And if it's a little off center, tap it, move it, tap it, move it. It's tedious, but you can get it back into center again if you didn't retain your mark. But that's important. And it's such a little thing. If you create your tenon and it was a little too long and you cut the end of it off, always remember to bring your tailstock back up again, if for no other purpose than put that indentation back in the dead center. It's a good bolt turning technique. You may always want that. Here's the process for building a chuck. And what I'm going to show you is my process for doing it using the acrylic material. Lots of ways of doing it. This is just the way I've chosen to do it. So let me take you through the steps of building that chuck. Let's take a few minutes.
First of all, I'm going to use a commercial faceplate. I'm going to find a piece of acrylic of the right size. I roughly turned this. I drilled and tapped these holes. This happens to be 832 thread. And when I screw this on into these tapped holes, I'm going to have a very tight, vacuum tight seal at each of those holes. But I screw it onto the side that still has the paper, because the paper is like a small seal. So I'm going to screw this on here. I've already marked for the diameter chuck I want, so I know where the outside of this is going to be. So for the material for the chuck, I've got to choose some type of pipe. This is all called Schedule 40. So I need my faceplate and screws. I have drilled and tapped. I'm going to fasten this down here. Then we're going to go to the lathe and put the vacuum hole here and dig a groove. Well, I'll probably take the short one here, that this will sit down in. See you in a minute. Back at the lathe, and we have several things to do. First of all, when I drilled and tapped these holes, I drilled them all the way through the plastic for two reasons. Number one, I'm using what's called a plug tap, which pushes the swarf out ahead, and I give a place for it to go. Drilling into acrylic gets hot, even when you're hand drilling or hand tapping. What happens is you have to stop and clear a lot. So I drilled all the way through, simply to make it easier. So this is never going to work without a hole in it. So I'm going to put a hole in the center. And I went back to the cabinet, selected one of our Morse taper drill bits at random. I'm going to put the hole in, right? So might as well do that right now. Don't want to drill too fast. All the way through. So now it's the vacuum chuck that's going to work. So I'm going to take my drill bit out. Now, my next activity is to come up here and dig a groove that this will drop down into. I laid this out ahead of time to mark the outside. And I need to find a tool that will cut a nice shallow groove. And I measured the wall thickness on this. And I picked up one of my parting tools. And I find my parting tool is about 3/4 of this distance. So I'm going to be able to cut in here, move over very slightly, and complete the groove. And I'm going to go slightly inside my mark just in case. Before I go too far, let's see if I'm on the mark. It's going to be okay. So it's going to take me a little while to dig that groove in here. I'm going to come down about half of this distance, and I'll be back in a couple minutes when I've finished cutting the groove. Okay, I've got my groove. What I'm going to do then is cement this into place. And then I want to do is retrue this edge to this whole system. This has to be exactly true to this lathe and this system. So I'm going to take this off, put a little bit of CA glue in here, put this in place, allow it to dry, and then we'll be back in a minute. I'm going to go off camera for a second, glue this, and we'll be right back to this place. Just finished gluing this in. Back to the lathe. I want to true this edge up and be sure it's running square and absolutely perpendicular to the axis of the lathe. All right. So now we know that edge is running true to the lathe. the next thing to do is to put the seal on. So I'm going to take it off and show you how I put the seal on.
So what I could have done is when I was gluing in the piece of Schedule 40 pipe with the epoxy, I could easily put a drop of epoxy on top of each of those screws. That would have then provided an additional seal. But I have found mostly the thread into acrylic has been a very snug fit, and it's worked out really, really well for me. So I thought I'd stop before we had put that foam on. I did want to show you one other thing, which I thought was kind of something we want to talk about a little bit again. We talked about these filters, these little inline filters that come cheap in pairs. In my setup originally, I used this as my bleed valve. It's a little rotary valve, and I thought it was really cute. And I found that it wasn't a very successful. This is what we call a ball valve, and it wasn't very successful because it leaked. The ones that worked much better were these lever kind. And the other thing about the lever is the fact that when it's closed and when it's open, it's pretty easy to know what position you're in. So I prefer these lever ball valves rather than this less expensive one that I got at Harbor Freight, which is wasn't successful for me. The other thing in hooking things up I want to avoid, I didn't mention this in the videos, is these are the quick disconnect that we use in our compressor connections. Don't do that. This is good enough for that, but it's not a snug tight fit. The other thing to avoid is mixing materials. I like all brass. It's been my preference. I don't use any of the steel fittings. So ball valve with less expensive ball valve, get a good one. It's going to cost you maybe $1 extra. And don't use any of these quick disconnects. They will all leak to some extent.
Question on your air filter, Jim. Is that specifically for vacuum, or is that a one that's also used with compressors? And if so, do you run it backwards for a vacuum?
Exactly. It can be run either way. These come with quarter NPT fittings, male and female, and there is a direction of flow marked on this body someplace. I don't see it right at the moment, but it is marked on there. Maybe it's printed here. So for vacuum, I want to be sure it's going this way. For pressure, I want it to go the other direction. When I take them off, I can shake them and pop stuff out of there, but change these things from time to time. I change mine about once a year, and I use it a lot for sanding. So therefore there's a lot of dust accumulation in this thing, but it's not that it's getting through into my hardware, but it's cutting down the efficiency of the system. So it's like an air filter where you don't clean the filters. Its filters even better, but it's not filtering near as much air. So it's important to remember to throw them away from time to time. And they're so inexpensive. This one, because it screws on, I've got to screw it into place. And being a quarter NPT, it screws snugly. And, then the other side, same thing.
So a follow-up question. I have read that on diaphragm vacuums, it's important to have a moisture filter also. Does this act as that, or do you run another filter to take out any moisture?
No, because the pump is after the system. How to say this thing? The diaphragm pumps may produce a small vapor of oil, which we have seen in the past off of ours. It's just a very light misting. At Los Lomas High School, where we set up a system like that, well, they actually put the pump in a box with a lot of open sides so that oil mist doesn't end up on the floor, and it needs to be replenished. But remember, we're sucking into the pump, not blowing out from the other side. So any mist is going downstream away from our
Let me
chuck.
rephrase the question, because
Okay.
my understanding was moisture gets sucked into the pump from the wood and can cause damage to the diaphragm.
Moisture could get sucked in through this, and I suppose you could put a moisture filter in place if you wanted to. I've never seen the need for it. I'm also not going to be vacuum chucking a piece of green wood that has high moisture content. I'm chucking at the very end of the making process, which means the thing's been dried and finished. And at that point in time, the worst thing that's going to come through is maybe a little bit of sawdust. But I've never had a problem with that. And it's an oil bath, so I figured that that's protecting the diaphragm also. So anyway, the system is set. The jaws are done. I just need to put that piece of foam on it to finish the chuck. So let's finish.
This is the closed cell foam we talked about. What I'm gonna do is put a bead of glue on here. And I bought this closed cell foam at Michael's, and I bought the foam glue that they recommend. It may be simply the same as normal white glue, but I'm going to use what they suggest. I'm going to put a small bead here, just around this edge. I know other glues may work equally well, but I've stuck with what they recommend, and I've not had any failures. So I've been perfectly okay. Make sure there's no gaps. And the process of sealing this on is really pretty simple. Watch this. Done. Now that's going to sit there. I like mine to sit at least overnight, if not full 24 hours. I don't know how long it takes for this glue to actually cure, so I'm not taking any risks. So this is going to sit here, and I'm going to go put this away, bring another chuck on that looks just like this, that has sat here for a full 24 hours to show you the final step. So this gets lifted away. And here's what it looks like after it's sat there for 24 hours. Got a piece glued on. I'm going to mount it back on the lathe again. And I now need to trim. And the easiest way to do that is with our trusty skew chisel. I sometimes come on with scissors and trim this down. But that part's trimmed. And now I want to trim on the inside and just the edge of the skew chisel. And here's a piece I can end up using on another project, smaller chuck. So it's done. We screwed it to a faceplate. We squared this up to the faceplate, dug a groove in it, glued on our plastic pipe, and glued on the seal. Now, sometimes over wear, these seals will eventually break down. Fine, I always have plenty of this. I retrue the edge, a little bit of touch of glue on it again, put another piece on. So there's your vacuum chuck. Any size, any shape you want, you can make.
It's as simple as it was. So comments, questions, issues that you're having with your vacuum systems that I might be able to put out here for discussion.
Jim, the question about Schedule 40 and PVC and the fact that it's kind of I suppose it's very important that it's Schedule 40, but the larger the pipe, sort of the weaker the pipe is. Does it really matter as far as when you get down to smaller sizes to use Schedule 40, or is that necessary?
No, it's not. And some of the stuff I'm using here are some of this smaller things that I was using was, this is irrigation pipe. So when you're installing an irrigation system in the yard for drip lines and so on, some of that pipe works equally well. Schedule 40 is a definition of, how do I say this? It's a relationship of diameter to ability to tolerate a certain amount of pressure. So as the diameter becomes larger, the wall actually gets thicker. The point is that it's designed to maintain an integrity up to so many pounds per square inch before blowing up. So a little small piece of Schedule 40 may have a wall thickness of 1/8. Bigger piece may have a 3/16 wall. So don't count on it being a constant wall thickness depending on the diameter. The other thing I've done is, there we go, sewer pipe. So we can go to all sorts of different places and get pipe. But I like plastics, and I'm in the plumbing department when I pick up my stuff, so I can use things from the garden department where I might be taking a piece of material for that, or I can actually use any size that needs to be. I have a chuck out in the garage that starts with 1 diameter and it comes down to a smaller diameter. So it's very rigid. It's very deep, and it's designed for things that have a large over projection. So, you know, just sometimes it's easy, sometimes it's just fun to make another chuck. Yeah, question,
Jim,
comments.
Well, I had a question. I put it in the chat too, and it seemed kind of strange because I was looking at putting one on my Nova, and listening today, there doesn't seem to be any reason why I shouldn't be able to do it. But I did contact Nova. I'm like, hey, do you have a recommended one? And they put in there, we recommend not using a vacuum chuck at all. Do you have any reason why they would say not to, or is it just somebody just on the other end typing an answer in, trying to get me to go away?
I can't think of a single reason. The Novas, the key is if that bore through the headstock is a solid integral piece, there's no reason that you can't attach a vacuum chuck to it. Now, it's not like the normal lathes where we have a bore going through with a pulley going to a motor. It's the shaft of the motor. But if there's no holes in it and it's steel or cast iron, I can see no reason at all for not doing that.
Okay, thank you.
With an oil pump, how do you handle the exhaust?
At school, at our school, Mount Diablo, I've never seen an oil mark from the pump. Although I know it will use oil, which means it's got to be going out as a mist somewhere. That's why the sight glass on the end of the pump allowing me to look at and see what the oil level is. There is no such thing, by the way, as pump oil. You're just using your standard compressor oil.
Regarding the oil-based pumps with the little fine mist, I saw a demo where a guy was using one of those. He had a tube on the outlet port, fairly big tube that went down into an empty detergent bottle, and the oil was all deposited inside there and didn't go anywhere else.
That's a great idea. Yeah, yeah. Big tube, so we don't want to restrict the flow on the outbound side. So, yeah.
I have a long tube on mine also, and I clip it to the outside of the door and it goes outside. I keep it above my head. I clamp it to the top of the door so I can walk in and out the door and everything is above me.
Keeps your hair slicked down then?
Hey, Jim, I have made a number of chucks, and a lot of times I'll use the nut instead of getting a faceplate and using a faceplate, because they're a lot cheaper than going out and spend $20 or $30. Drill the hole, set it in, and I have no problem, in sealing it with epoxy and everything. Where
those 1x8 fender nuts are really great because they're known to be flat, and so you have a 1x8 thread. I've not found 1 1/4 8 fender nuts. I found 1 1/4 7, and I was just looking yesterday to see if I could find any nuts that were 1 1/4 8 thread, which is an oil industry standard. For some reason, we've adopted. And I found one source, and the nuts were, I think, almost $50 a piece. And so I figured I'm going to continue to look.
is that the fender nut or just the nut itself?
Just a nut, not even a fender nut. Yeah.
When when the chuck goes on the lathe, this seal here is a metal-to-metal seal. Is there any advantage of putting a Teflon washer in between?
Yes, if your chuck doesn't have a good flat surface and the mating surface on the headstock is not good and flat, then a Teflon washer in there is great. That provides, oh, I'm showing you something I didn't put on the camera. Commercial faceplates, this is nice and flat on most of them. I've not had a seal problem, but I can very easily see that that could be a seal. If this has been scarred, if the headstock has damage to that face surface, that nylon washer is a great idea, Mike. I think that's that worked really fine. As it seats down, that's good. And I've just never had a problem with that. Mine have seated very well. I have one chuck that I made out of a non-commercial faceplate. I don't know where it is here. I didn't bring it in. Bill Tarleton, a friend of mine who passed away a few years ago, used to make faceplates. And Bill's faceplates were made out of nuts and washers, and that back surface was never flat. So I had two choices. Either I've got to find a way to square that to the axis and make it dead flat, or I'll put that washer in that you're talking about, Mike. That's exactly the right thing to do.
Okay.
I was able to, because I have a metal lathe, I was able to chuck up his faceplates and retrue that back edge of that nut. And it's not available to most people.
The other thing I just wanted to point out, Robert Chucky sells a replacement. I haven't used it yet. I just got it in a couple days ago, but we'll see.
Replacement for what?
For the gasket.
That's anything else. I may be speaking to the people who are already into using vacuum chucks and have gone through and solved many of these problems already. But I'm
Jim,
certainly willing
I have a question for you.
Okay, great.
So
Cindy?
I put in the system that the original, I took a class with you and put one together, and I used it for a while, but then it seemed like the pressure gauge stopped working. So what do you recommend? That I take the whole thing apart and put it back together?
The pressure gauge that's not working, or is it the vacuum system?
It might be the pressure gauge that doesn't seem to be going up very much. And I wasn't sure whether to open the valve all the way and just let it pull as tight as possible.
I've not found a vacuum gauge fail for me, but I've made sure that my debris filter precedes it in the line. If the gauge is between the filter and the pump, let me see, if the gauge is between the filter and the pump, that's good. If the gauge is on the headstock side and the filter is downstream, then very easily you could suck debris into that gauge and it could lock it. It could bind it up and not allow it to move properly.
Okay, so I need a filter is what I need. Sounds
you
like.
definitely have to have a filter in the system, and that filter needs to be before any of the hardware.
Okay, great,
Yeah,
thanks.
so what I would do is I'd take that thing apart and I'd start banging it onto the tabletop and see if anything falls out, a little dust and debris. Well,
all right, I'll try it.
I don't know if anybody be interested, but I made a chart. I know you can barely see it, but I can send it to you guys. And it has the size of different diameters, and then it tells you what in the vacuum, what you're pulling, what the pressure is that how much pressure you're putting on your parts. So it's kind of fascinating. If you had a 10-inch diameter and you're pulling 25 inches of mercury, you're putting almost 950 PSI on it. Okay. And then I have one other question.
Yeah.
You don't put a radius when you make your end of your vacuum chucks, you don't radius them, you just leave it flat?
Oh, good point. I do not have a sharp square edge on these chucks. These edges are slightly radiused over, just enough to break them. If this was really sharp and I pushed a bowl over the top of this like this, what could end up happening? I could end up cutting that piece of foam.
Yeah.
So yeah, I do break that edge. I don't really round it. I guess
'Cause
it
I've
could.
had it where, like on those phenolic ones that you buy, they use an O-ring, and if you have a little too much pressure and you're inside of a bowl, it'll leave that, the plastic will leave a cut mark right into your bowl.
Yeah, good point. It's sort of like when we use jam chucks and we put a piece of foam pad in there and then jam it on, they're always going to leave some impression on the wood, easily sanded out in most cases. But if you've got a sharp corner in there and that impresses deep, that's a problem.
Yeah.
It's a problem. Yeah, good point. Okay, anything else? Well, I've enjoyed it. It's been kind of fun to get together and do one of these sessions. We need to keep this process up. So we're always looking for people who have something of interest to share. The setup you need is a iPhone or a laptop, and not much more than that. Actually, you don't need much. I did a presentation once about just using the camera in your computer to do everything you needed to do to show things. And there's no reason I couldn't have held these products up and shown them to you like this equally well. I just had a chance to go a little bit farther, but it doesn't take a lot of technology. And Dave and Jim and I are more than happy to be helpful in setting up a process for you. I'm going to sign off and thank you all for being here and paying attention. And I appreciate your inputs. Thanks.
Thank you, Jim.
Thank you.